recording, so we got to keep moving. So you guys show that you are a fantastic class and be interactive and get everything right. Yep. All right, so here's the deal. I'm changing the way I'm doing something moving forward, and I really hope it doesn't make it more confusing, but I'll be honest, it might. But right now, too many people are missing it. I had 2 people out of, and not all of you did it, but most of you did it, like did the bell work. So 2 people out of, like, we'll say 15 got that completely right. The first step, not even the whole problem. I just mean the first step. So, and I'll give you guys your quiz in 7 minutes. Those of you that need to take the quiz.
Oh, you have to combine the 3 with
Well, I'm going to show you what it is.
Wait, did you get it in because I figured it out? I didn't put 9.
Well, it's not about the 9. That's not even what it's about. So here's what most of you did. Like I said, all of you but 2 that did the problem. We do distributive property first. So you guys are pretty good with that. Some people, I don't know if in this class, I don't remember, to be honest. There might have been one person that tried to say 9, subtract 3 first. We don't subtract 9 and 3 first. We do, phones up, especially those of you that didn't do the bell. So we say, all right, well, the 9 is not even part of the real lesson that I'm going over right now. We said, all right, well, I need to take the 3 times 3x, and then I need to say 3 times 2. And we say that comes out to be 9 subtract 9x plus 6 less than 15. That's what most of you did. That's wrong. That's wrong. That's incorrectamundo. I'm about to tell you how. This negative sign here has got to also be distributed all the way through those parentheses.
Oh.
So what I'm going to start doing, I am no longer going to use a subtraction sign unless I just absolutely forget that I'm not doing it that way. Everything I do is going to be plus, and every number is going to have either a positive or a negative sign on it. But all my math will be based on addition. And this is how that's going to change. So it's going to, for some of you, it's going to be significantly different than you've ever seen. But I'm hoping it clarifies this whole inability to.
How are you going to change it?
Well, I'm about to show you. So here's what I'm going to do moving forward. I would rewrite this problem, and I would say, well, this is really 9 plus negative 3 times 3x plus 2 is less than 15. So if I don't write a sign on a number, it means it's positive. Every number is either positive or negative. But I don't need to write positive on a number for you to know it's positive. You assume a number is positive unless you see a negative sign on it. So just real quick, if that's throwing you off already, adding a negative is the same thing as subtracting. I'll give you an example. Let's say you're playing a board game. Let's say it's got a board that's just labeled with numbers. That's not enough numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, I get to show off my artistic ability when I do this, so that's another reason why I do it. I'm a fantastic artist. There you are, you're on square 10, right? You draw a card. The card says go back 3 spaces. That's the equivalent of giving you or adding a negative number, adding a negative 3. So if you get that card and it says go back 3, that is plus negative 3. It's telling you to go back 3, it's giving you a card, it's giving you negative 3. So you go back 3 to 7. Now you're on 7. You don't look as good on 7 as you looked on 10. that's the same thing as saying 10 subtract 3. So adding a negative is the same exact thing as saying subtracting that number is positive.
Somebody's knocking.
So I am from now on going to always be adding. Thank you. Can't read it. It is for you. How did you know that? Are you leaving? You're leaving? Thinking something else? Oh, all right, hurry back. You don't want to miss this lesson.
Yeah, don't miss this one.
You get a big bonus at the end of the day. Assuming you guys are doing what you need to be doing during the class.
Yeah, Mrs. Governor.
Are you just asking me if I want you to take your earbud out? Yes, I want you to take your earbud out. Not supposed to, but it's not yet. Pencil sharpener is back there, and then there's one for knives. The pencil sharpener back there, just beware, it can eat your pencil alive. So I will from now on write this as or subtraction as a plus and then the negative sign. So this subtraction sign is just always going to become a negative sign with the next sign. Simple as that. So Lillian, is that how you go out? Thank you. That's what I wanted. Thank you. No phones, no earbuds, and no attitude. I don't accept any of them. Thank you.
Wow.
All right. So going back to the problem then. So now if I write this out and I say 9 plus negative 3 times 3x, and then again plus, because I don't do subtraction, negative 3 times 2, now the math works out and I get the right answer. So plus negative 9x plus negative 6. And some of you are actually writing the plus negative 9x and plus negative 6, which I love, because that keeps it all pretty clean when you do the problem. And you won't make that mistake of not, because the problem is if you come out with a negative number, if you don't come out with a negative number, remember when we solve an inequality, we do the opposites. So when you go to get rid of this number, if you've got positive 6 instead of negative 6, then your first step is to subtract instead of add, and then that changes the whole end result of the problem. You've got to get those positives and negatives correct so that you can solve the rest of the problem out correctly. Because adding 6 versus subtracting 6 to that number makes a big difference in the answer, obviously. All right, so I'm not even solving it all the way out. That was just, you will see me moving forward. I'll never do subtraction unless I just totally forget. I'll do plus the negative number. So now we're moving into a new lesson. So here's what we're doing today. Last week, really, your last grade that you will earn is today. This is it, except for those of you that have to take a quiz today, which is now. So you're going to get an exit ticket at the end of today. It's going to be a pretty decent size, and it goes in as a quiz grade. So it's going to be a pretty decent sized quiz grade. It shouldn't be hard because it's going to be on the exact same things that we go over today. So I know you haven't been here for a lot of this, but take it and see what you can do. It's just solving a plan. So I gave you 2. Who else? Oh, there we go.
Smile in your face? Yes. Why can't smile?
I'll go over some of this stuff with you guys that are taking it. Don't do number 7.
I really would.
Really? All right. I mean, your time. Taking up I feel like there's somebody else I'm missing.
You missing me?
I need one.
You didn't take a quiz? You took the quiz. I know. I remember what you got on the quiz. I'm gonna tell everybody now.
Oh, what I got it?
It was pretty decent though, because you had said you thought you failed it. And you got a pretty decent grade on it. Everybody actually got a pretty decent grade on this one. Well, I shouldn't say it. The average was pretty good. The average.
Well, guys, you got
Oh,
this.
you want 1, 2, 3, 4.
Well, you gotta get last grade, you can get this.
All right, so you can go ahead and start working on anything you can do, and then when Ms. Hope gets here, you do not, for those of you taking the quiz, you don't do number 7. Throw in number 7 out. I didn't already say that. All right, so here's what you guys in class can go ahead and write. This is the lesson we're doing today. Actually, you can copy down all of that. Even including, well, that's a horrible number line. So copy all of that other stuff. I'm going to wind up moving the number line. What in the world?
I have a question, Mr. Gill.
Yes.
Is this period 7 or 6?
6. You do tend to write 7 on your paper sometimes. There we go. Well, shoot. I'll scroll back up in a second so you can copy that down. Oh, actually, I can freeze it for you guys. You guys online. Oh, but then you guys online can't see it. All right, if you're online, copy that down real fast because I'm going to have to leave the screen briefly. Oh, somebody's trying to get on the line or asking me a question or something. Let's see what somebody said. Oh, all right. Yeah, I think in person is much better. You were doing pretty well in person. When you were here, you missed a lot of days, but so yeah, come back face to face. I like that idea. All right, so you guys online, finish copying that down. You guys in person, finish copying it down too. Did you move your seat?
It's been like that for like the past 2 weeks.
Yeah.
For the past 2 weeks?
Yeah.
Shayla
Don't
was just
think
here.
so.
I'm just joking.
Shayla sits there, so I don't think that's possible.
You just don't notice it?
No, I noticed her. That's totally in violation of COVID policy.
Dang.
Saying if they have to do COVID tracking now, unfortunately, you're gonna make Sakira go home, and then she's gonna have to quarantine too. If you have COVID.
I don't got COVID. I stay home. Why I gotta go?
When they go back and do the COVID tracking, now you're sitting next to her instead of 1 seat away from her. Hopefully you don't.
On Friday, I'm gonna be sick right away.
All right, so I'm gonna change it real quick. You guys can still see it. Well, you guys in person can see it. People online are the ones that are gonna have to wait a second. All right, there we go. That didn't take long. All right, so you guys should be done copying that. Oh, so I forgot to tell you what's on the line with the exit ticket. So here's the deal. When I do an exit ticket, not always, but this one is definitely the case. If I feel like you guys have been engaged, like meaning you've been interactive, you've been answering questions, you've been doing what I ask you to do, like if I say now grab this, and I walk around and everybody's graphing it, or I won't say everybody, I'm not gonna let 1 or 2 people ruin it for everybody else, but if you are, as a class, doing pretty much what you should be doing, the exit ticket winds up being really easy. I help a lot. Now, if I don't feel like you're engaged, then you do the exit ticket on your own and you get whatever grade you get. But normally, people are pretty good about it on days when I do exit tickets, and they know that I'm gonna help them if they stay on task. So just stay on task. If other people are getting off task, politely help them get back on task. Yell and scream. Get mad at people and make people get defensive. That doesn't do any good. You guys are a pretty good group. Y'all know each other pretty well. So. For the most part. All right. So we did inequalities, and I have a really super simple inequality here. You go into a store with $5. You have the variable x representing how much money you wind up spending. What did we say x could be when you go into that store? What are the numbers? Let's just throw out some numbers to start out with. You go in with $5, how much might you spend? How much might you spend? How much could you possibly spend?
$3.25.
You could spend $3.25, $3.25. Well,
$4.99.
you could spend $5. You spend exactly $5, right? You spend $4.99. $2. What else?
You just wanna go in there.
$1.50. What else?
Zero.
$0. There's one we could spend. We could go in and not spend anything at all, right?
We spent 50 cents.
We could spend 50 cents. 50 cents. So, relative to 5, what would our inequality symbol be? Like, what are all those numbers when we think of them, like where they would be relative to the number 5? They're all here, right?
Yeah.
So, right. So they've got to be less than. We can't spend more money than we have. So they have to be less than, but, as Fernando said, could also be, I think you said 5, I know you said 0. Could also be 5, right? We could spend exactly 5. So we said when we go in, we can't spend more than we have. So that was our graph. And then we graphed it, because now that we're doing inequalities, we wanted to graph it. And we said, all right, well, that means I draw the line here, I shade it. First step is to put the circle on the number. Then we shade. The shaded area is our solution set, like the amounts that we could spend. And there we go, boom. Piece of cake. Now, I think I actually mentioned this at one point. We'll see if anybody actually listens to me. What's wrong with that? Oh, good point. That's actually not what I was talking about. I skipped step 2. I didn't shade in the circle because I had an equal sign underneath there. What's wrong with that still? I've done something wrong. I'll give you a hint. Hey, the graphing's not wrong. It's actually my original inequality that's wrong for this particular scenario. There's a problem based on this being a real life situation. I'm not really doing the right thing based on this real life situation. What's the real life situation? Yeah, the story. Like, what's the story? What did I set this up with? Kinda. I do like asking people to tell me a story sometimes when we get to work. So, once upon a time, we were doing what?
We were hungry.
Yeah, we're going to the store, right? We're going to buy stuff. We're going to spend some money. So what's wrong with my equation? Really, my graph, it's easier to see probably. So what's wrong with this? I'm going into a store to spend money.
You don't got your mask on.
What do you mean I'm losing? Oh, both of you are on to it.
So it's supposed to be negative.
Can I spend -1?
No.
Can I spend -2? I can't spend negative money. Now, by spending it, I'm giving it away. We're talking about X is the amount we spend. I can't spend -$1. I can't spend -$2. I can't spend anything that's negative. I can spend $0 up to $5. That's what I can spend. And that's it.
You can steal from there.
So, this technically is not the correct inequality or the correct graph. Thank you. Let's get off track. That technically is the correct inequality. We should be saying, yeah, boy, you think I'm going on. He's just hanging out at the door, probably not. You can put that up on the desk and get to work, please. So we should have kind of actually added in a piece that said, well, yeah, the amount we spend, or X, has to be less than or equal to 5, but this part means it also has to be greater than or equal to 0. That's what this symbol means when the X is on the right side of it. So it means 0 has to be less than or equal to X, but we never say the 0 first. We say the variable first, so it means the X has to be greater than or equal to 0 and less than or equal to 5. This was actually, turns out, when we did the exit ticket in the last class, this was something that they did not understand. The fact that, so it's the same symbol, right? Like we've got the same exact symbol, but that symbol does not mean less than or equal to in both of those situations. We always look at the symbol based on where the variable is relative to the symbol. So x, here it's pretty clear. X has to be less than or equal to 5. But here, x has to be greater than or equal to 0. So this part right here, and again, this is the only thing that they really missed on the exit ticket. So if you want to get 100%, this is the part that you, about the only part I think that anybody had trouble with was this part right here. You have to understand that when x is on the right, the way we read it is from the perspective of where the x is. So if x is like that, this symbol is, remember the alligator, they teach the alligator thing? Yeah. The alligator eats the bigger number, right? So I'll make it larger so I can show you. So that's your alligator mouth, that's your alligator mouth. The alligator eats the bigger number. So that means x is greater than 0, even though it's the same symbol. But the variable is on the right-hand side in this case, and it's on the left-hand side of the other case. So you really need to understand. Joe, you can probably head. He's doing a quiz if you want to take one something.
Oh, I get it. Take me too. Take me.
You want to go? Is that what you're saying?
Take me.
Yeah. Let's take a mayor.
Mr. Gill. Mr. Gill. I told you I won't be there. I'll be on the field.
That's for anybody else.
On your team. Sorry.
No, you can do
I'll
it.
be on the field.
Oh, Shaq? Yeah, Shaq.
All right. So if you can remember that, the alligator eats the bigger number. And you always want to think of it relative to where the x is. So if the x is on the right, then you would say in this case, x is greater than or equal to 0. If you remember that, then this wasn't too difficult of an exit ticket for the kids today. Most of them got A's and B's. Even if they got that wrong, they still got a B on it. Assuming you pay attention and stay engaged. Yeah, let me just erase that real quick. So, oh wait, I didn't mean to erase it.
Oh, bathroom, please.
You're up next. So our real equation was this, which means our graph would have actually been this. So that's what our real graph is. We need to take away those negative numbers because negative numbers can't be included. Like we can't spend negative amounts. So that's what the real perfect graph would look like. It would only be that we could spend $0 all the way up to $5, and that's it. We can't spend the -1, -2, -25 cents, anything left of that 0, we can't spend that amount of money. So go ahead and I would make sure that you understood that this is about money. That's why it's kind of like that. That's probably a pretty common type of question they would ask. They wouldn't tell you it's necessarily an inequality or a compound inequality. They would just tell you it's about money, and then you'd have to understand that that means you can't spend a negative number, negative amount. So the other way you will see this written, this means, again, x is greater than or equal to 0, and x is less than or equal to 5. Oh, you know what? I'll bet when I hit delete, yeah, sure did. Oh well, all right, so I'll have to rewrite it then. Ooh, you guys can't really see that, can you? Can't. Can you see what's in green there?
No, I can't.
All I see is,
And.
and it's just the equation, inequality is just equation or. I'm trying to read it. I just read it.
Why can we even read? Here.
How about now?
Arrogant is a bum.
So it says.
Wait, those are mine.
All right, please refocus. An equation or an inequality. We're dealing with inequalities now, but this is going to be the true for equations when we get back to those. They are just like a rule or a requirement we have to meet. That's really what they are. So our rule in this case is x needs to be greater than or equal to 0 and less than or equal to 5. That's two rules technically. So that's our two different rules. If we have two rules like we do here, that's what makes it a compound inequality. Like if it would have just said x has to be less than or equal to 5, that's just one rule. That's just a normal inequality. But if we have two rules, so the way you can also write this, there's two ways. One I've already written. And that word's very important. So we could write it like that, as two totally separate rules. And you will see it written like that sometimes. Or we could write it the way that I have it written here. Like that. So this is the same thing for this type of problem. You would read those the same exact way. X is greater than or equal to 0 and x is less than or equal to 5. You'd say the same thing down here. X is greater than or equal to 0 and x is less than or equal to 5. Just make sure you shade. This is the third step. Shade the direction left to right. Ah, boy. So I had this up there on graphing for them. I want to show you guys. Remember, if there's the symbol underneath, so this thing means you would shade the circle in. If it's less than, so Jakin, oh, she left. Oh, she's that's all right. She's in there. So for Cassie and Jakin, I said if it's that or that, either of those two symbols, you shade left, like for your third step. So you put the circle, you fill in the circle, and then you shade left if it's one of those two. If it's not one of those two, then you shade right. But I got to get rid of that. So just remember that. You may want to write those two down real quick. And then if it's got the line underneath it, that's when you would fill in the circle. So there was a whole page that I had up for them. Oh, I think it's changed, but on the first page, is the equation, did I put +1? Yeah, so that means 2g plus 1. I didn't figure that out already. Yes, that means 2g plus 1. Didn't figure that out already. All right, so here's what we're doing. There's two types of compound inequalities. So basically, you're going to have two little inequalities that are going to be joined by either and or. This one was and. So this is one of the kind of ands. We're going to do a few with and then we'll do a few with or. And on your exit ticket, you have some with and some with or. So again, phones, earbuds, they should all be out. Please.
Be out.
Like not in your ears. Correct. It's going to be an issue. Kind of coming on. So there are rules that everybody needs to be following. That's for a reason. All right, so here's our next page.
Copy that blue part down.
Just, well, this part, the and then the blue part. And then we'll get to the next part.
Two.
Aaron. Aaron. Jacob changed the name to,
Big two.
Do your work.
something cheese.
Oh, God.
All right, so there's a pretty simple way, I think, to do these different inequalities. It wasn't as simple for the kids as I thought it was. So we'll see how you guys do it. Are you still writing? Oh. All right. Can you see it? Both rules must be true. Graph these as separate. Zoom in a little bit. There you go. Couldn't see it. I'll give you another minute. So online, you should be writing all this down too. Everything I do online, you guys especially should be writing it down, since you don't get the full effect of seeing what I'm kind of doing when I'm pointing at stuff and all that. And you're gonna have to do the exit ticket like I said, so you probably need these notes. Working, writing. The exit ticket at 30 minutes plus 10, so 40 minutes. 40 minutes. What was the question, Nicole? You're going to, so you might as well. Mainly it was the blue though. It's like if you've written the blue, then I'm going to move on and you can kind of do the other part as I do it. All right, so we're done with the blue.
Not yet.
I will keep writing and I'm going to go ahead and start kind of talking about it. So some of what I'm going to say is already in the writing part. So if you're writing it down, you'll get it. So what it says for an and. So again, a compound inequality with an and is just an example is what we just did. It's going to be two different little inequalities. They both have to be true. That's why we use the word and. We had to be greater than or equal to 0, and we also had to be less than or equal to 5 in the example we did with the money. They both have to be true. That's the key in an and. They both have to be true. Both rules must be true, meaning each inequality is thought of as a rule. Like you have to be greater than -2, and you have to be less than 3. So here's how you're going to do the graphing for all ands, not just this one. They'll look different as the final product, but the process is the same. You just treat each one of these inequalities separate, and you graph them separately. Now for you, it's going to be a little trickier because you don't have multiple color pencils. I mean, you can. I have them back there. But for those of you that choose not to do that, which a lot of you will choose not to do that, it's a little trickier when you only have one color that you're writing. And I'll show you in a second how I would do that as well. So I take that, I shade to the right because I need to be greater than that number. And I'm not going to shade quite as thick, I guess, as I do normal because I need to be able to see a little more clearly when I have a compound inequality. So there's one of them. Again, you just graph them separately. For your first step, there's 2 steps when you have an and, at least, not when really before an or. But. So now let's do this one. All right, so I'm going to come in. So again, I write a circle on the 3. Because that's the beginning of it. If I'm ignoring the fact that there's red there. Don't even care about the red yet. I'm doing this as if it were the only inequality. Can I shade? Oh, didn't like the way I ended that. That's fine. So there. And I shaded this way. Did you say something, Maureen?
You said you're coloring this, right?
Oh, back there in the box. You guys want to use one? They're not already down, just mention it and I'll grab them down, or you guys can feel free to grab them, just put them out for people. I was gonna say, yeah, put them on a desk there, or the middle desk. So, we did them separately. Technically, this is totally against COVID stuff, so you really shouldn't be. I shouldn't be allowing you guys all share pencils.
But look at you are.
I know you guys do things a lot worse than share pencils. Here's where the different, you're gonna do this same thing when we get to the OR statement. You treat each one as separate inequalities and you graph them both. Here's where the difference comes in, right here. If you get this, you should be pretty good on not only the exit ticket, but then the rest of the lesson when we come back on Friday. For an AND statement, again, this is only for AND, what I'm about to say. Only for AND. Our solution set, our final answer to this, because right now we've just done the first step. Our final answer is the section of the number line where our two graphs that we created overlap. Overlaps means we have both of them there. So here we only have green. Here we only have red. Here we have both. That's our solution set where we have both. So remember when we did the problem about the money going into the store, we had to be greater than 0, so it was in between the 0 and the 5. Again, we have to be greater than -2, but less than 3, so our solution is in between those two numbers. Same concept. When you graph it though, no matter what type of numbers you have and symbols, if you do this process, just shade both of them separately and then look for where you have an overlap, where you have both of the shadings, both, in this case, both of the colors, that's your solution. So my final solution, what I would really need to do, because since you don't have two colors, it'd be kind of hard to do it any other way. Do you all have this down? So I'm about to get rid of it. Everybody has that graph down with the two different things on it? Here's how I would do it if I had only one color. Same process. I put a circle on the 2. I don't fill it in, the -2. It needs to be greater than that. I would just above the number line do a line like that. For the next one, I would do a line below the number line to represent my shading. So do it below the number line. Now you can very clearly see where you only have one line shaded, which would be the end still. I only have one line, I only have one line. You don't count the number line, don't consider the number line when I say one line.
It's only if you're not doing two colors, right?
Yeah, if you have colors, then you just use the colors. So the only place I have both of the lines is, again, like we already said, in between the -2 and the 3. So that's not your final answer. I mean, I guess you could leave it like that as long as you specifically somehow tell me. The better way to do it, the cleaner way to do it, just to make sure I don't. Because if I can't tell, like, some people think that if they leave it all messy and everything, that I'm going to just give them credit because maybe they did the right thing. No, I'm the opposite. Like, if you didn't clearly give me an answer, it's wrong. Like, I'm not going to spend hours and hours and hours when I do these tests trying to figure out whether or not it's right. I need to clearly see that you knew how to do the problem. So this would be the real way to do it, is then draw a second graph. After you do both both inequalities on one graph, draw a second graph. Oh, I'll put it up on the desk. So then you could draw a second graph and only draw the section where you had both of the two lines, or the two different colors, or whatever you want. If you're doing two different colors, I guess you could say my answer is the place where I have red and blue, or whatever your colors are, green and yellow, whatever your colors are. So, and then you could say in between the -2 and the 3. The problem with that is sometimes you have to fill in the numbers, and then you'd have to also say including the -2. So it'd be better to do the second graph. I'll think about how I want you to do that for Friday. All right, so that's the first way. Oh, and remember, when we graphed this, and I already said this, but this is the same thing as, what was it, -2. So x was in the middle, because it had to be greater than -2, but less than 3. X is in the middle, the shaded region is in the middle of those two numbers. So it follows that same pattern when it's an AND problem. Now, not all AND problems look like this. In the last class, or maybe even fourth, they thought every AND problem looks like that. This is only one type of AND inequality. So there are other ones that will look different, but when it's in this format, the shading will always be in the middle of those two numbers, just like the X is in the middle of those two numbers. I want you to graph this one. Use same number line. You can draw another number line, -5 to 5, and graph the next one at the bottom. So this one right here. You guys try to graph that on your own. And I'm not saying it's like the one above it. You need to graph each of them separately, and then see where you have overlap, where you have both lines. And see if you can tell me what, don't tell me out loud yet. I'll call on you in a second. Right now, just try to graph both. That work. Practically just like that. I would use your notes. Yeah, see what I did there? Apparently so with that one. Shade. I've literally been doing inequalities all day long. Yeah, if you shade, you're actually not in horrible shape on that picture, because your word drawings look pretty good. So finish the shading on those graphs on the first page, and you can probably be done. How many people are done with this? They know what the answer is. They're good. Yeah. Let's see what everybody's doing. Okay. So write down what you think the answer is, like in words.
In words?
Yeah. And.
What the hell?
Because remember, the first step is to graph each of them individually. The second step is to graph what is the actual, or if you want to graph the final answer, do a second graph and graph the final answer. What are your, well, I want you to, like you shaded here and here, I want you to shade which direction you would go.
I did this very on one second.
Kind of have, there's what a less than looks like, that was in blue. There's what greater than looks like, that was in yeah, pass is up there on that far down.
So one goes out and two goes out.
No, yeah, later.
Yeah. No, she's down.
Oh.
It's racing, yeah.
So what's the final answer? Do a graph now, graph with the final
Like
answer.
that in the X? Like that?
Well, I don't know. That's what you gotta tell me.
That way.
There's a reason why the graph looked like that, because that's where they overlap. Because remember, when you do an and problem, where they over, oh, I like it. What's your final answer? Well, the final answer here was we did this line and we did that line, and the final answer was that part right there. That's what they both read in.
Okay, I get it.
So, what's your final answer? Those are your two individual answers.
It's the gear.
I know how to do it.
Think about it.
It's just like that, the negative two.
You all know how to do it.
Although I did it right.
Have to think. You have to think about what you're looking at. We said the final answer,
Oh,
And you shade it like this, right?
where your individual.
sorry about that.
You do that one first, on its own, like ignore that you have this. Then do the other one, just like you don't have that one. Come on. So when you graph greater than 2, this is greater than 2.
Is this right?
Do that. You tricked my
1 is greater than 2, 0 is greater than 2.
So I gotta go this way?
What about negative 1? Negative 1.
No.
Is this greater than negative 1?
Sorry, I
Less
went
than
the
negative 1?
wrong way.
Is that any of that in here less than negative?
Don't you just write that one?
So you have two graphs. Well, again, that's greater than negative 1, and less than.
Jesus Christ.
You're graphing these individually, like, don't look at what we did up here. You guys are all looking at the first example, it's not the same example.
Like this?
Exactly, it's not the same example.
Yeah.
So
I
I
just,
think you shaded that little darker.
I forgot
That's
one.
the two individual
I
graphs.
forgot a few.
That's the two individual
Wait, I dated him for a second.
graphs of those.
I need a
What is
land
your actual
knowledge.
answer?
We gotta get some.
The answer is where you have the overlap, where you have both of them.
Yes.
Like, when we did this problem, we had a line that went this way,
Cross your eyes.
and then we had a line that went this way. And I don't know if I matched the colors up right. Oh, I did actually, yeah. The reason this middle section was our answer is because we had red and green there. We had both of the graphs graphed there, shaded there. That's why this middle section was the answer, because we had red and green. This we only had red. This we only had green, so that's not part of our answer. So you need to look and say, well, where do I have both of the lines shaded on my number line?
Oh.
So where do you have it? You have both of them on 5, 4, 3, 2?
Oh, go.
Can you?
I have
You have
one.
one of them on 5, 4, 3, 2.
I'm just gonna put.
I mean, my brain
Uh,
is.
this
This
is-
does not make sense.
My brain is shrunk very much.
Do you have both of them here? Both there.
This is right there, now he's like mixing it with.
You're saying that both of the I graphed both lines in the middle of these points. Yeah.
So then that's right.
Let me see, just to make sure I get it right.
You have one here
I
and
get
one
it.
there.
What
You
the
don't have
hell?
anything in the middle,
Oh.
so that can't be it. You don't have any of them.
Same
It's
thing.
gotta be both of them.
Just look at the jury.
What the hell?
Well,
What's
no,
the-
I tried.
there's no place you have both.
You gotta give me something that is $10, and then you got the $10.
So I didn't expect necessarily anybody, some people get it every once in a while. You are third, well, second in line.
It'd be like $2.
That's,
Well, let me ask you this, so you're saying in between, right? You have both lines in between them.
That's not six right there, you still got $4
I
left.
can do that. You have both be in between, whatever. What's that? There, I know, that's not right. So where are they both?
You got pizza there?
on the number
You
line.
can see something about pizza, but they got pizza.
Yeah, but not both in the same spot.
Right here.
Where are they both at?
Someone had to go.
They're not both, they're not connected. There is a one, two,
Is it you next?
space.
All right, so I'm gonna go ahead and stop this madness, because I think one person knows now, but that's not it.
No, I know.
So let's graph them real quick. Now that most of you have done
Can I
them
do it? Can I do
correctly.
the graphic? Please, just let me do it.
Come on.
I'm gonna do
I love people doing that. The only reason I never do is because of the whole COVID sharing thing. I'm already letting you share those, so come on.
Can I go the other side?
Yep, cool. You can go through one.
All right.
There's actually
What color
a
you
dual,
want?
there's a dual mode where I can normally let you do it at the same time, but I don't know how to set that up, so do it individually.
So, you go like this?
So do it in different colors, obviously.
Oh.
There we go. Perfect. I like it. I like it a lot. All right. And then there's the other one. Looks good to me. All right. So we have both of those graphed individually. What is the rule when it comes to our final answer for an and inequality, compound inequality? What do we say the rule, like, not the rule, that's the wrong word. How do we determine where our final answer is?
Where they overlap?
Yeah.
It's where you have, if you're using colors, it's where you have both colors in the same place.
But they don't.
Do we have the same, or both colors in the same place anywhere on that?
So,
No, this is all red, this is all blue, that's nothing.
So what's the answer?
no solution.
No solution.
Oh,
There
wow.
isn't one. No solution to that. There is no, remember how we had no solution in some equations when we solved them out? We got 2 equals 4, or something like that, like that just didn't make sense.
So that's.
This is the same case. There is no solution to this problem. There is no number you could ever have that meets both of those rules. It's a special, unique scenario, which means you'll probably get tested on it because it's unique, and they want to know that you understand the unique scenarios, even though they almost never happen. Well, actually, they almost never happen. All right, so same thing. Do this one down here. This one does have an answer though. This is not super special. All right.
Okay, I can't see.
All right, there's the first step I think you would get. If you look really look at
After
it.
she goes. Sebastian, are you gonna?
I think there's 2 more already.
Yeah.
Who's in line? Were you waiting?
What happened?
I'm gonna go to Steve grade.
Just one?
Who asked? 'Cause I did.
I went to the
Oh,
bathroom.
okay, so I knew, wait,
No, I had to use the restroom. Remember, I was like the first in line.
you did
I
it.
ain't used
Right, I'll let you go.
You can
I
have
thought you had already.
I
gone.
don't have to go. Malik, so, and then somebody else.
Thank you for letting me know. Yeah, I think you asked a while ago, right? Okay. All right, I thought you had already gone, so I'm sorry, I probably skipped over you. All right, so you're definitely next, because I think I skipped you. And then Everett, and then I'll let you.
How about it? Oh, wait, Steve can go before me.
Oh, wait, you just went.
No.
Oh, you, I didn't remember you had to go.
Oh, I did.
I thought you were just saying that Everett had to go. All right, so then, yeah, then.
Can we do another one like that?
Well, you're doing this one right here first.
Oh.
No, I'm sorry, I thought you guys heard me. We got off on the bathroom thing. So grab, that one, I said that one does have a final solution.
Oh, you said.
Yep, there is a final, so I'll scroll down a little bit so you can see a little bit better. We got a few more to try, so yeah, we got a lot of. These are harder than the next ones we do, which are called the OR situation, but we have to get to those because they're on the quiz also. This one will have a final solution. Are you done, Jacob? Jacob? No, you're not done. You haven't done anything.
Man,
Hey, wake up.
Slap his neck.
Slap him, just slap him.
It is not, this is not hard. You got, I want to say you got like a B or something on this first test. This is the same thing, only it's got an inequality sign there instead. Two-step inequality, that's it. You do 2 things.
That's early?
And then you just graph it. We just graph through the bell.
Isn't your shirt like Maryland? Oh, look.
Yes, it is Maryland. You're the turtle. Buddy of mine actually went there. I had no allegiance whatsoever to them, but I thought it was kind of a funny shirt. You're the turtle. I laughed at him when he told me what their mascot is. I was like, your mascot's a turtle? And he's like,
My mascot is a gator.
Go Gators. Oh, I know, we got postponed last week against LSU. I was looking forward to watching that. I watched Georgia and Alabama. All right, so you should be doing this. I'll walk around. Looks like you didn't do it.
Yeah,
Are
I
you
did.
giving the wrong sense?
I just don't know how to put it in there.
What do you write?
Question.
So they overlap, so you don't have to put it in Word. You would just redraw the graph. Everywhere they overlap
That thing.
would be your answer.
That thing.
How can you write the example?
It is green. That thing. X. That thing.
How do you wind up doing so well on this? So what's your final example, your final answer for that? You just drew a graph, it's just your answer solutions. Well, let's say, which I want you to do, draw a graph with just your solutions. The solution set is just where do you see red? But that's the only part, just the place where you see the red.
Miss Gill.
So where do you see the red and blue?
Yeah.
So you redraw the same graph, 5 by 5, and you would just draw from there.
Cheese ball.
So what else?
Just the area where you see the red. I know you weren't here for a lot of this, so I'm just.
Placement.
Yeah, well, I know, I took place math.
Yeah, it's really just out.
This is literally my thing, but I don't remember. What's it not?
ASSY.
It's out.
ASSY.
Oh my god, I can't believe I.
That's weird.
No, like,
Uh,
nothing.
It was
I was
ASSY.
gonna say, you're not at all. You're doing fantastic in class.
What, like 500 times to get off of the
I
phone?
mean, that looks pretty good, so. You
But I
don't know what to do on this one at all? This one you didn't have to do.
But I also didn't.
Aaron,
SSY.
Aaron, I heard
Yeah,
you
I
were
can't, that's why I.
Eighth grade girl, right? Y'all.
I know, shoot, but
I heard
then
that.
what am I gonna do? Like,
Well, don't worry about that. I just want you to see
Sorry.
this part has a person.
Was you for real?
You got
Oh, Venus.
But then he
It
just
was
like
cloud
Bro.
on the bus. It was
Well, you can do more, like combine those, which actually get you points. So if you can do any more of it, do more of it. That was good.
under the bus.
You're under the bus.
Yes.
And you even use a third color.
That's how dead I was.
So I want you to draw,
Hold on.
so I want you to draw a bunch, you got a bunch of stuff going on, so I want you to draw a second graph.
I'll take out the back.
And then tell me exactly what your solution is, like which part of
You're gonna
this
be a
you're
whole
gonna
nother
keep
wheel.
this part. I'm gonna do it in a second if you don't understand that part. You have to understand that part to be able to get the questions right,
I
okay?
thought they were lying, so I had to ask.
Somebody just said that.
Me, is this correct?
So technically what you would do is you draw a second
They
graph.
told me and
And
I
you would
thought they were
just
lying,
draw
so I
this
asked
piece
you.
right
You
here.
just.
Feel like a nine.
Me.
Okay?
Ah, you
So,
probably lied. You
and
probably
if
went
you
over to her house and
this,
just
that's
like
what you would
cuddled.
So you just see.
You didn't. Look at him. You didn't smack.
I'm pretty sure. You got a video on it, I think. I don't remember for sure, so if you didn't, I'm sorry, I apologize for telling you that, but I want to say you did.
I told her.
Yeah.
You can use that for your quiz,
Yo,
if you copied that work now.
She
And now you
lies.
use that to do this part right here.
Wait, I have one. Red.
y'all, I'll bring her up after school.
Let me see that. Let me see
Not
that.
really.
Let me see that.
Ask her.
Uh,
Alright,
wait.
Bryce.
All right, so
Sorry, I don't wanna get.
refocus, we gotta get going, because I got a whole nother section to tell you before you do the exit ticket. You're doing the exit ticket no matter what, so. All right, so this is probably the last and one we're gonna do, then we gotta move on. So again, first step, I ignore this part and I just do that one. It's gotta be less than -3. Well, that's going that way. All right, next step, it's gotta be less than 4. That's going this way. You guys are getting that. You're pretty good at doing them each individually. Here's the part where you gotta make sure you understand though. Please put phones up. Please put phones up. This is directly related to your very large exit ticket question today. And a lot of you are not completely getting it, and I'm not going to help you on the, well, we'll see. Depends on how the next 10 minutes or so go. Oh, not 10. Oh, I got to really get, no. No, 12. So, here's your final answer. That is not your final answer. All right? That's the first step when it's an and. Your final, or an or really. Your final answer is to say, okay, so everybody had that. I graphed each of them separately. There. So here. So my final answer, again, I just duplicated the number line. My final answer would be, all right, where do I have red and green? Well,
3, 4, 5.
Everywhere left of the 3, the negative 3, right? Everywhere left. I can't include the negative 3 because that's technically in the circle, the open circle. So I would put an open circle on the negative 3, and my solution to this one is everything that goes to the left of negative 3. Yes, and you do need to draw a whole nother graph. For and, at least you do. You won't have necessarily for the or, you'll see in a second. So that, because otherwise, when you don't have, now if you have separate colors, if you want, but see, then you got to tell me way too much stuff and you're going to miss something. You could tell me, well, it's everything left of negative 3. I guess that might work. Everything less than negative 3. I might be okay with that. I'll think about it for Friday.
Hey, yo.
Whoever's next. All right, so now on to the next one. These are much easier. I think they won't take a super long time. Go ahead and graph those. Oh, and you want to write this down. So write that down, and then once you're done writing that, go ahead and graph that. So
It's the same thing.
No, yeah, or now. There's an or now. It says an and.
Quiz grade, you don't have a bunch of grades in it. Some of the grades you have are zeros.
You just started.
From here. Which I'll have to figure out how I'll talk to your other teachers and see how they're handling it. So technically you're on the roll, and I've been giving everybody that hadn't been showing up zeros, but you showed up, so I don't know what we're gonna do. So I'll figure that part out, but if you, the more grades you get in, and this will be an easy one, so just try to follow along, and I'm gonna help out probably on the exit ticket anyway. So again, write all that down. Then once you're done writing the stuff down, go ahead and do the graphing for that one.
We stopped at a circle.
Like, don't stop at like 3. Keep going past it.
Go past the words.
That's what we normally do.
I don't know.
Two-step equation.
Aaron,
Two things, and then you got the answer.
That's a teacher.
let me think about
No,
that.
you just don't put an equal sign. Put that sign instead of the equal sign.
Rule could be true.
Yeah, same steps. Inequalities and equations are the same
So
exact
we're trying to
steps.
find which
There's
ones.
one thing that's different, potentially, but even if you forget that, and you do everything else, you get a B on those problems.
What do you mean on top of the circle?
Inequalities, but on the same graph.
Just graph it, and I'll show you what that means later. Right now, just graph it. It won't matter for this first one anyway. This, don't worry so much about this, don't stop at the other circle, because it doesn't come into play for this graph. It'll come into play for the next one. It'll come into play for the next one. You can do this one without understanding what that means. It's just a mistake that sometimes people make, students make. So I want to make I'm going to kind of get started on it myself so that we can be ready for the exit ticket. Like I said, I think these are easier, so. All right, so I'm going to go ahead and explain what this means, even though I know some of you are still working, but there's only one of these on the exit ticket, and I'll give you a hint, so you know. No, not yet, no. But I'm going to go ahead and tell you, since we're running late, there's one on the exit ticket like this. This would be a good one to pay attention.
Oh, man.
And yeah, I was really supposed to get through everything on this for the other classes. So when we graph an OR, you guys keep working and you can check back up in a second. It's kind of the same concept. We still do both of these individually, which is what I just did. I graphed the equation or the inequality on the left. I ignored the other one in green. Then I came over and I graphed the inequality on the right, and I ignored the one that was in red. So I graphed both of them on the same graph. Here's the difference. Like I said, I told you when we started this that the process was the same for the and compound inequalities and the ORs. The difference is in how you tell what your solutions say. If it's an OR inequality, what it's basically saying is our solution can come from either of these. It doesn't have to meet both of them. If it meets either of them, then it's a possible solution. So if we just said every number is less than 2, those are possible solutions. But then if we look at this, well, also every number greater than 3 is also a possible solution. So in this case, once you graph them, that's your answer. Everything you graph, you just leave them both on them. You don't have to.
That's your answer?
For that one, that is your answer. That's the easiest of the different kinds. So you just missed what I said, so I'll go over to second again when we do the next one. So now technically you should draw another graph and do that over again, and but I'm not going to make you do that, especially not in the extra. So our answer again, it could be either of these, which means we just leave both of them on the number line. So now do this one. And then after this one, we'll I don't know. It's important, though, that you understand that when it says x can be less than this or greater than this, what it's saying is it doesn't have to meet both of the requirements or rules. If it meets either of those rules, then it is a possible answer on your graph. And these numbers in between don't mean either of them. Like 0 is not less than -2, but it's also not greater than 3. So it doesn't mean either of them. So if it's not shaded at all, those are the only ones that are not one of your solutions. I'll do that one in green. So less than 2 will be going that way. Greater than -3 will be going this way. So this is sort of also a unique situation. So I'm recording this. If any of you are way behind, you're freaking out, don't worry. This is going to be recorded. I don't know if any of you actually go back and watch it, but if you do care, you're freaking out, don't freak out because this is recorded. You can see all of this online and watch it again. Now, we just again did both of them separately. You should have come up with something that looks like this. One number is shaded to the right, one number shaded to the left, but they overlap a little bit. So in an and, like if this would have been and, not or, what would our solution set be in there? Anthony, what would our solution set be if this was an and problem? And we just graphed both of those. You remember? If you don't remember, that's fine. It's first day, I know that. Yeah, so you weren't watching either. What would our solution set be if it was an and problem instead of both? Do you remember? Somewhere you were doing quizzes. Mariah, do you remember?
It'd be in a good part.
It'd be where we have both colors, right? If it's and, we have to have both colors. If it's or, we just have to have one color. That's the way to remember it if you're using colored pencils. If you're not using a different color pencil, then you just have to have one line. Well, where do we have at least one line on this graph, this number line? Where'd you say? Well, at -3, we have at least one, because we have the green one at -3. Where else do we have at least one? Positive 1, we actually have both at +1, so yeah, we definitely have at least one. Where else do we have at least one?
0.
0, where else?
-1.
-1, where else? -2, where else? All we have to have is 1. We don't need to have red and green. We either have red or green. Where do we have either red or green?
3.
3 works. Where else?
4, 5.
Is there any place where we don't have at least 1?
-4.
No, we got green. Is there any place we don't have red or green? There's not. There's no place. This is kind of like the unique scenario for the or compound inequality. What do you think the answer to this one is? Well, any of them, but the way we say that in math, infinite. Infinite solutions, every number.
I can just do that little 8 thing on the side, right?
Every number. If you want, that's fine. Every real number is an answer to this. Because any number you pick is either going to be less than 2 or it's going to be greater than -3. There's no number you can pick that won't meet that. There is another or situation. I might just for the purpose of the recording, I might do it while you guys do the exit ticket. So you're going to need to, when I put it on the exit ticket, copy all 3 problems, leave yourself plenty of room underneath each problem. So same way for you guys that are online, you're going to be doing the same exact thing, because I'm going to have to leave the screen. Oh, actually, yeah, no, I'll still have to leave the screen for you guys here too. So get a piece of paper out. You are turning it into me, so get a blank piece of paper out. If you need scratch blank paper, there's tons of it over there. You don't want to waste one of your own piece of paper. This is a good size grade. Do not forget to put your name on it. Do not forget to turn it in. And then just pay attention, because I'm going to basically give you some pretty big hints on it. So I do want you to copy all 3 questions down and leave plenty of space under each one to do it, because I'm going to wind up leaving the screen to come back here and finish this out for the recording. Oh, I hate it when it does that. There we go. All right. So here, ooh.
Answers, thank you.
Well, that's not the answer. God, what is it doing? Am I going? Oh, there we go. All right. So let me zoom out a little bit. Oh, you're killing me. God, it's like a huge delay or something. Really driving me crazy here. Exit ticket is where? Huh. Where is the exit ticket? Is that it? Is that it? Is that it? There we go. I'm going to get rid of all of that. Don't worry about it. So here you go. Here are the 3 problems. So write those down. Again, leave yourself some space. So this top one, the X is in the middle. What does that mean? when you graphed it?
And.
It means and when you graph it, what did it mean it would look like? If the x is in the middle of the numbers here, the shaded region is in the middle, remember? If the x is in the middle, when you go to shade it, the shaded region should wind up being in the middle when you kind of do your second final graph. None of these have any equal sign underneath it, so they're all open circles. So don't even worry about filling any circles in. You might shade the circle because you shade a section of the number line, like, or something like that, but don't fill in a circle when you do it on its own. One that's the or, remember I told you there was one or that looks exactly like that one problem that we were going over at the time, so that's that one. So again, for this top one, similar to when we spent $5, this is like you only had $3 going into the store. You're going to say, well, x is greater than 0. How does that look? Well, it'd be every number to the right of 0. X has to be less than 3. Well, that'd be every number left of 3. And then for your final answer, your final graph, you would make a graph that just had those numbers in between the 0 and the 3.
So you want us to do two graphs?
Open circles. Yeah, because this one you do need to have a second graph because of the fact that they're open circles. Because otherwise you'd be shading through them and I wouldn't be able to tell what your final answer would be. So you should have open circles on 0 and 3, and then the final answer would have the shaded in between. So for this one, I'll give you a really big hint on this one. So that's your graph. You'd say, all right, well, I need x to be greater than 0. Well, it needs to be greater than 0. I put that there. That would be greater than 0. That was my red. Well, I also need it to be great, and it's an and problem, so I also need it to be greater than 3. So if it's and, how do we determine our final solution? If it's a compound inequality with and, which section is our final solution? Trying to help you guys out. Somebody say something. So what's our final solution if it's and? Which part of the number line?
The middle part.
Not just, it's not always the middle. Nope, not always the middle. What? It's where we have both. If you're using different colors, it's where you have both colors. If you're not using different colors, it's where you have two lines. You graphed both lines. So the only place we graphed both lines, or I use different colors, the only place I have both colors is everything to the right of the 3. I have red and green, or I have both lines to the right. So this section does not count because even though it's greater than 0 right here, it's not greater than 3. So we can't use that section. It's got to meet both for an and. And then the last one, like I said, that's that little scenario where you do an or, you graph both of them individually, and then you just pretty much leave them there. They're both possible solutions. So if you just do this last one and just graph both of them individually, then you're going to be good. Remember, a lot of kids up on this top one in the other class, they were thinking this meant that x had to be less than 3 and less than 0. It's not that. X is greater than 0 because it's on the right, and that's where the alligator mouth is going toward the x, but it's got to be less than 3. So when you graph it, just make sure you keep that in mind. And then, like I said, the middle section in between the 0 and the 3 is your final answer. You need to have the numbers on there Like, don't just do this and expect to get 100%, but it winds up looking pretty much like this. Like, that's the graph where we said we had the arrows going out, and the middle is empty. But again, you need to have the numbers on there. Don't just do it without the numbers and expect to get. All right, so I'm gonna get rid of that. I'll freeze it for you guys in class. You guys online, hopefully you got that down. I'll come back to it though if you didn't, but I do want to wrap up this recording and finish the or examples. So here are the final or examples for those of you that are watching the recording. So if I had an example of x has to be less than 3, or x is less than, we'll say, -1.
It's very hard. Okay.
I would come in, I would say, all right, well,
Look. Shut up.
first I would graph one of them. So I'll do the first one in green, I guess. I'll do this one in green. Let's say, all right, well, it's got to be less than 3. So I put a circle there, and then I graph to the left. That's less than 3. And then I'll do the next one in red. So x needs to be less than -1. Circle on the, and then I graph this into the left because it's still less than. So with an or statement, anywhere that I have a line, I don't need both lines, I just need either line, red or green. Well, I have green all the way from the 3, the +3 to the left. Final answer would just be what's graphed in green. Everything to the left of +3. So that's another or situation, kind of the final or situation. They could have both said greater than, and it would be pretty similar. But that covers everything, all of the ands, all of the ors. Really quickly, just for the purposes of trying to show it, this is a whole bunch of different scenarios and how the graphs look. I'll zoom out so I can maybe fit all that. Not quite. Make sure your name is on those exit tickets, please. So there you go. Just turn it in up here. I thought people were putting them down. Oh, maybe not. I'll collect them. So here, that's a whole bunch of scenarios. Just hand them to me. Don't leave with it, though. You need to make sure I get it. Thank you. Thank you, thank you, thank you. Thank you, thank you, thank you. Thank you. Hopefully everybody put their pencils back. I don't know if they can spray pencils. All right, so I'm stopping the recording. You guys that are online, you need to send me that. Upload it to Focus. If you're really having trouble uploading it to Focus, and it's in the exit ticket on Compund Inequalities is the assignment you upload it. It's should already be in there. If for some reason you can't do that, just go ahead and email it to me in Canvas because I need to make sure I get it this week so I can grade it. And you need to get it to me like soon, like in the next 10 or 15 minutes. It's due today. I don't see any questions online, so I'm gonna go ahead and end the meeting. Talk to you guys later. Oh, what's that? Karina, I have a meeting. What was that? Oh, they had the last two, not normally though. I guess because we had a quiz and then we had to take it. Finishing those
You
up.
know what that lady took the Jasmine and that one thing?
Oh, yeah, I need a quiz. That's probably down right there.
Okay, cool, because I had to type it.
Where do you want us to put the coloring pencils we use?
Should've-
There they are. Where's Miss Hope?
She's in
Still
there,
with-
yeah.
or with Jasmine?
Move.
Jasmine's probably coming back. I mean, if you want to take that out, I think she can.
Are you staying in here?
Oh, yeah, I've got actually a meeting with a student at 1:30.
See you later.
See, let her know that. When she comes back-
You can put the exit tickets on that stack right there, and then those, just put them back in
When she comes
that.
back, can you let her know all her
Yep,
stuff?
I will. Thank you. Whoop.